We started Newton's third law of motion. Very simply I explained you that what does Newton's third law of motion states. It simply says that to every action, there is an always equal and opposite reaction. To every action, there is always equal and opposite reaction. And how did we learn this? We learned this by this example. You can see a table A and a block B which is kept on the table. ठीक है ना? टेबल ए भी दिख रही है, टेबल के ऊपर रखा ब्लॉक बी भी दिख रहा है, और लॉ क्या कहता है कि हर एक एक्शन के लिए एक इक्वल और अपोजिट रिएक्शन होता है. ठीक है, अब देखो इस केस में मैंने आपको एक्शन रिएक्शन कैसे समझाया था, अगर आपको याद हो. मैंने क्या बोला था, व्हेन द ब्लॉक इज केप्ट ऑन द टेबल, ब्लॉक इज ट्राइंग टू पुश द टेबल डाउन. ठीक है ना, जब ब्लॉक रखा हुआ है टेबल के ऊपर, ब्लॉक क्या कर रहा है, टेबल को नीचे पुश करने का कोशिश कर रहा है. टेबल में ऐसा लगाओ कि आप छेद करके टेबल के पार जाने की कोशिश कर रहा है ब्लॉक. ठीक है, ब्लॉक क्या करेगा, टेबल में छेद करके उसके पार जाने की कोशिश करेगा. ब्लॉक विल ट्राई टू मेक अ होल इन द टेबल एंड विल ट्राई टू पेनिट्रेट द टेबल. सो द ब्लॉक विल अप्लाई अ फोर्स ऑन द टेबल ए which we will call as FAB. FAB बोलेंगे उस फोर्स, क्या बोलेंगे, FAB. FAB is force on A due to B. जो अल्फाबेट बाद में लिखा हो ना FAB में, वो अल्फाबेट तो फोर्स लगा रहे. Here you see the B is coming after A, so B is applying the force and force is getting applied on A, so FAB, force on A due to B. Now to counter this force by the block B, अब block B टेबल पे फोर्स लगा रहा है, मैंने आपको बताया FAB वाली. इस फोर्स को काउंटर करने के लिए एक अपोजिट फोर्स लगाएगा टेबल ब्लॉक पे. ठीक है, टेबल विल अप्लाई एन अपोजिट फोर्स ऑन द ब्लॉक B to counter this force FAB, and that force will be known as FBA. That force will be known as FBA. FBA. What is FBA now? Force on B. FB देखो B पहले है ना, the B is written first, so force on B, force on B due to A. Okay, due to A. So force on B due to A, FB. Now both of these forces are in opposite direction. देखो एक दूसरे के opposite है ना, both of these forces are opposite in direction, but they are equal in magnitude. Okay, जो फोर्स ब्लॉक ने टेबल पे लगाया FAB, और जो फोर्स टेबल ब्लॉक पे लगाएगा, वो दोनों एक दूसरे के इक्वल होंगे, लेकिन डायरेक्शन अपोजिट होगा. ठीक है ना भाई, ऑब्वियस सी बात है. ब्लॉक टेबल पे लगाएगा तो नीचे की तरफ लगाएगा, और टेबल ब्लॉक के ऊपर लगाएगी तो ऊपर की तरफ लगेगी, क्योंकि ब्लॉक टेबल के ऊपर रखा है और जो टेबल है ब्लॉक के नीचे है. सो ये कॉन्सेप्ट मैंने आपको कल सिखाया था. ओके, दैट द डायरेक्शन ऑफ बोथ द फोर्सेस विल बी डिफरेंट but the magnitude will be same. So you can read rest of the definition from here. Okay, I will not repeat this. मैंने कल repeat कर दिया. Conditions for action reaction pair. What are the conditions for action reaction pair? Action reaction pair मैंने आपको बताया. What does action reaction pair? These forces which are equal in magnitude but opposite in direction. The forces which are equal in magnitude but opposite in direction constitute the action reaction pair. Finally, ठीक है ना guys? I gave you example also. Action reaction pair किस तरह के होते हैं. Another example which I gave you about action reaction pair is that you must have seen a hot air balloon rising up. So how does a hot air balloon rises up? Hot air balloon कैसे ऊपर जाता है हवा में? बैलून क्या करता है, बैलून से निकलने वाले गैसेस जो है वो नीचे अर्थ की तरफ जाती हैं, वो अर्थ पे फोर्स लगाती हैं, उसे बोलते हैं एक्शन फोर्स. ठीक है, जो बैलून से निकलने वाली गैसेस ने अर्थ पे फोर्स लगाया. सो व्हेन द गैसेस आर गेटिंग रश्ड डाउन by the balloon towards the earth, that is called action. And in reaction the ground is pushing the balloon upwards. Okay, so do you understand action reaction pair? I will give you another example similar to this is of rocket propulsion. Whenever a rocket propels in the air, rocket जब हवा में जाता है तो आपने देखा होगा नीचे से बहुत तेजी से आग निकल रही होती है. What is that fire when the rocket is going upward? That fire is burning of fuel. The fuel of the rocket burns to produce exhaust gases. That exhaust gases hit the ground. Okay, that is the action on the ground. That's the action force. And in reaction, the ground pushes the rocket upwards. दैट इज द एक्शन रिएक्शन पेयर. Another example of action reaction pair is when you walk on the ground. जब आप चलते हो ना उसे भी एक्शन रिएक्शन बोलते हैं. ये जब आप चलते हो तो अपने पैर से ग्राउंड को पीछे की तरफ धक्का देते हो, ठीक है ना. You push the ground towards backward by your feet. That is the action. What is the reaction? In reaction, the ground pushes you forward. जो जमीन आपको आगे तरफ धक्का देती है, that is the reaction. तभी आप लोग चल पाते हो. Action reaction pair. ठीक है. So this was it. The conditions are very simple, that both these action reaction forces occur simultaneously. It is not like that the force applied by the block on the table will be at let's suppose 10 seconds and the table will give reaction at 20 seconds. ठीक है. दोनों के बीच में there will be no time lag. कोई टाइम लैग नहीं होता है. जिस टाइम पे ब्लॉक टेबल पे फोर्स लगा रहा होगा उसी सेम टाइम पे टेबल पे ब्लॉक पे फोर्स लगा रही होगी. तो बोथ ऑफ देम ऑकर साइमल्टेनियसली. साइमल्टेनियसली मतलब एक ही समय पर, एक साथ. अपोजिट इन डायरेक्शन समझ में आ गया ना. अपोजिट डायरेक्शन कैसे हैं? व्हाई दी फोर्सेस आर अपोजिट इन डायरेक्शन. सेकंड पॉइंट इज एक्टिंग अलोंग द सेम लाइन. नाउ दिस इज आल्सो आई एक्सप्लेन्ड इन द लास्ट क्लास. यू कैन सी बोथ द फोर्सेस by the arrow. You can see in the arrow the yellow arrow and the red arrow. Both of them are acting along the same line. Okay, and what is the line? Line is a simple line which is joining both the systems और both the objects. जो ब्लॉक और टेबल को ज्वाइन करने वाली लाइन है उसी के along दोनों फोर्स एक्ट कर रही है. तो ऐसा नहीं है कि एक y एक्सिस में एक्ट कर रही है और x एक्सिस में. बोथ ऑफ देम आर एक्टिंग इन द y एक्सिस. ओके, इट्स जस्ट कॉल्ड द एक्टिंग अलोंग द सेम लाइन. लाइन ऑफ एप्लीकेशन सेम है. ठीक है. व्हाट लाइन ऑफ एप्लीकेशन बेसिकली होता क्या है? जैसे कि सपोज करो Malini is pushing a wall. Okay, and Anurag is watching Malini, and Anurag says, "Okay, Malini, let me help you in pushing the wall." ठीक है. So Anurag also starts pushing the same wall. Now Anurag and Malini both are pushing the same wall. That means they are applying some force against the wall, and since both of them are applying the force against the same wall, we can say that both of them are the forces exerted by Malini and Anurag are acting along the same line. ठीक है. दोनों ने जो फोर्स एक्सर्ट करी, दे आर एक्टिंग अलोंग द सेम लाइन. दोनों वॉल को पीछे की तरफ पुश कर रही हैं. ओके, डायरेक्शन सेम है, मतलब नॉट डायरेक्शन सेम नहीं है, बट जिसके तरफ एक्ट कर रही हैं वो चीज सेम है. वॉल इज कॉमन. ठीक है. what else? Act on two distinct objects is just simply means कि both the forces action reaction will act on different objects. Action देखो हम we push the ground backwards when we walk, so that is action. Action forces applied on the ground by humans. ठीक है. And reaction forces applied by the ground on humans. तो देख रहे हो ना, दोनों फोर्स अलग अलग ऑब्जेक्ट्स पे लग रही हैं. ठीक है. एक्शन हम चलते हैं जब, तो हम ग्राउंड को पीछे पुश करते हैं, उसे बोलते हैं एक्शन फोर्स. हमने ग्राउंड पे लगाई. और रिएक्शन फोर्स हम पे लगती है, ग्राउंड हमें आगे धक्का देता है. सो दैट इज द रिएक्शन फोर्स. तो बोथ ऑफ देम एक्ट ऑन डिस्टिंक्ट ऑब्जेक्ट्स. डिस्टिंक्ट मतलब अलग अलग ऑब्जेक्ट्स पे एक्ट करती है दोनों फोर्सेस. एक्शन रिएक्शन ऑलवेज एक्ट ऑन डिस्टिंक्ट ऑब्जेक्ट्स. एंड लास्ट पॉइंट इज दे आर इक्वल इन मैग्नीट्यूड and have same nature. या they are equal in magnitude. I've told you जितना आप एक्शन लोगे उतना ही रिएक्शन मिलेगा. ओके, ऐसा नहीं है कि जैसे कि अपने में होता है ना कि सपोज करो मैंने किसी को एक थप्पड़ मारा और उसने मेरे को 4 थप्पड़ वापस मार दिए, दैट इन एग्रेशन. वो नहीं होता यहाँ पे. यहाँ पे ऐसे होगा कि जैसे आपने वो कैसे एग्जांपल दूं मैं आपको, वो ऐसे मुझे स्पोर्ट्स याद नहीं आ रहा एक्शन रिएक्शन का एग्जांपल देने के लिए. नॉट एक्शन रिएक्शन, बेसिकली इक्वल मैग्नीट्यूड का वो देने के लिए. have you seen that game in gaming parlors में? आपने देखा है मॉल्स में, with a hammer you have to strike a button and then a bar goes up and tells you how much high have you scored based on how much with what force you have hit that button. आपने अगर वो गेम खेला है तो बटन को हिट करते हैं ना हथौड़े से, फिर एक वो लाइन जाती है ऊपर तक, बताती है कितने तेज आपने हिट करा ना. तो उस वाली गेम में देखो, अगर आप दो लोग सेम फोर्स लगाओगे तो वो लाइन एकदम सेम पॉइंट तक जाएगी. ठीक है. तो वो इक्वल मैग्नीट्यूड का मतलब क्या है? सेम फोर्स लग रही है, सेम नेचर वाली. सेम नेचर सेम कैसे है? दोनों पुशिंग फोर्सेस हैं. ठीक है. ब्लॉक इज पुशिंग द टेबल डाउनवर्ड्स एंड टेबल इज पुशिंग द ब्लॉक अपवर्ड्स. दोनों एक दूसरे को पुश कर रहे हैं. डायरेक्शन अपोजिट है लेकिन नेचर सेम है, पुश ही कर रहे हैं एक दूसरे को. ऐसा नहीं कि टेबल ब्लॉक को अपनी तरफ खींच रहा हो और जो है टेबल भी ब्लॉक को अपनी तरफ खींच रही है. बोथ ऑफ देम आर पुशिंग ईच अदर अवे. Okay, so this is Newton's third law of motion for you. Force on FAB is equals to minus FBA minus QI because direction is opposite. Okay. Now, action reaction forces always act on different bodies. Force always these forces are always exerted in pairs. Okay, and every action has equal and opposite reaction. These are the things which you have to keep in mind. ठीक है ना, दोनों एक्शन रिएक्शन डिफरेंट बॉडी पे लगेंगे, जितना एक्शन होगा उतना ही बराबर रिएक्शन आएगा, उससे ज्यादा नहीं उससे कम नहीं. ठीक है. नाउ लेट मी ड्रॉ केस. लेट मी ड्रॉ. ये थियोरेटिकल क्वेश्चन है आपका, ठीक है, ये न्यूमेरिकल नहीं है. आई एम गिविंग अ थियोरेटिकल क्वेश्चन. यू हैव टू थिंक एन आंसर. कंसीडर कि मैंने क्या कंसीडर करोगे. कंसीडर दैट आई हैव केप्ट अ ब्लॉक ऑन अ टेबल. यही सेम एग्जांपल ले लेते हैं. येलो कौन गया. Okay, this is a table. Imagine this is a table and I have kept a block over it. Okay, a block. Block B I've kept on the table and this is table A. Same example. Okay. Now just tell me that weight of the block will be acting downwards. Weight, देखो, weight तो नीचे की तरफ एक्ट करेगा, ग्रेविटी तो नीचे ही लगती है ना. So weight of the block will be equal to mg, mass of the block times gravity. Weight is acting downwards. And I told you about normal reaction. नॉर्मल रिएक्शन के बारे में आपको बताया था ना, मैंने बस टेलिंग यू टाइप्स ऑफ फोर्सेस. मैंने आपको नॉर्मल रिएक्शन के बारे में पढ़ाया था. सो द नॉर्मल रिएक्शन इज always exerted by the surface of one body on the another body perpendicular to it. ठीक है ना, perpendicular समझते हैं आप, 90 डिग्री पे. So this is your normal force. I've told you, I'm confident. मैंने आपको normal force पढ़ाया था. What is normal force? I've told you. अब जो लोग क्लास में नहीं थे उनको रिकॉर्डिंग देखनी पड़ेगी, but I've told you this ना. What is normal force? Contact force में मैंने आपको फ्रिक्शन और नॉर्मल दोनों बताया था. बहरहाल मैं रिपीट कर देता हूँ. Normal force is exerted by a surface on another surface and which is perpendicular to its own surface. जैसे टेबल ने ब्लॉक पर लगाई तो टेबल से परपेंडिकुलर है, वो टेबल के सरफेस से परपेंडिकुलर है और ब्लॉक के सरफेस से भी परपेंडिकुलर है. यू कैन सी दैट. ओके. This normal reaction force is exerted by the surface of the table on the block and it is perpendicular to both the surfaces. So normal reaction is always perpendicular to the surfaces of the objects involved. ठीक है. This was a case. Okay, now you have to now imagine that this block is trying to push the table in downward direction and the table is trying to push the block in upward direction. Okay, due to these forces. If I say that because of normal reaction the table is trying to push the block upwards. ध्यान से सुनना, अगर मैं ये बोलूं कि टेबल नॉर्मल रिएक्शन लगा रही है ब्लॉक के ऊपर और उससे वो क्या कर रही है, ब्लॉक को ऊपर पुश करने की कोशिश कर रही है. ठीक है, तो ब्लॉक को हवा में उड़ जाना चाहिए ना, क्योंकि ब्लॉक के ऊपर फोर्स तो लगा रही है ना. तो ब्लॉक को इस वजह से क्या हो जाना चाहिए, उड़ जाना चाहिए, हवा में उड़ जाना चाहिए ना, टेबल पर टच तो नहीं रहना चाहिए. अगर टेबल ब्लॉक पर मैं कह रहा हूँ एक नॉर्मल फोर्स लगा रही है तो उस फोर्स का कुछ तो रिजल्ट होना चाहिए. देयर शुड बी सम रिजल्ट ऑफ द नॉर्मल फोर्स. इफ नॉर्मल फोर्स अप्लाइड ऑन द ब्लॉक बाय द टेबल, दैट टू इन द अपवर्ड डायरेक्शन, then the box should lift up from the table. Box should lift up, it should not touch the table if table is applying a force in the upward direction, but it does not happen. The block remains there only, है ना, because there is another force on the block which is pulling it downwards. That is the force exerted by the earth on the block. The force exerted by the earth on the block is your gravitational force W, which is equal to mg. This is the another force which is acting on the block, which is pushing, or I can say not pushing, it is which is pulling it downwards. Okay, one force on the block is normal reaction, which is pulling the block, pushing the block upwards, and the another force is the weight, the gravitational force, which is pulling the block downwards. Okay, so because of these two forces, the block is neither flying up or penetrating downwards. It stays where it is. So the two forces, now you know what are the two forces on the block. So these two forces, can you call them can you call these two forces balanced? First of all, tell me, can you call these forces balanced? Balanced force, you know what is balanced forces? Balanced forces कराया मैंने आपको? Let me check. अगर नहीं कराया तो I will explain you balanced forces पहले. But I hope I explained you balanced forces क्या होते हैं, unbalanced forces क्या होते हैं. Basically, when there are more than one forces acting on a body simultaneously. Balanced forces का मतलब बताऊं आपको. What when there are more than one force, एक बॉडी पर एक साथ एक्ट कर रहे हैं, more than one force is acting on a body at the same time interval, and these forces do not bring any change in the state of rest or the state of uniform motion of the body, then so hence we can say that the forces acting on the body are balanced because they are not producing any acceleration. ठीक है, जीरो एक्सलेशन प्रोड्यूस कर रहे हैं. हिंदी में रिपीट करूं, बैलेंस फोर्सेस क्या होते हैं? जब एक ब्लॉक के ऊपर बहुत सारी फोर्सेस एक ही टाइम पर एक ही समय पर एक्ट कर रही हो और तभी भी ब्लॉक ना, या अगर रेस्ट पर है तो या तो मोशन में ना आए और या तो मोशन में है तो रेस्ट में ना आए. इसका मतलब क्या है कि फोर्स की वजह से कोई चेंज नहीं आया. सो फोर्स इज प्रोड्यूसिंग नो चेंज इन द स्टेट ऑफ रेस्ट or the state of uniform motion of the block or the object on which they are acting. Okay, this means that the forces are balanced in nature. When there are different forces, more than one or more than two forces acting on a block and producing no net result, that is they are producing zero acceleration. So that type of forces are called balanced forces. So now you know what are balanced forces. So tell me, whether what do you feel that normal reaction and the force of gravitation, are these two forces can be called as balanced forces acting on the block? Can we say कि block is acted upon by balanced force? Just think and tell me. And generally, I'll tell you one more hint. Generally, these two the balanced forces are opposite and they have the same magnitude. Okay, generally the balanced forces on a body are opposite in direction and they are having the same magnitude. Magnitude means the measure of force. Okay. Yes, Malini.
अरे
अरे Malini, क्या हुआ? अरे, what is the word अरे? Have you ever wondered? No problem, Malini. गलती से तो हो गया. I'm asking, have you ever wondered why do we use the words अरे, अबे, ओए, things like that? They're very loose kind of words to use. One should never use these kind of words. Okay, a friends में चलता है, but like when you are, you know, in a very professional environment, for in a very formal environment, you should try to avoid these words. टेंशन में, अरे मैं आपको डांट नहीं रहा हूँ, मैं आपको जस्ट सिखा रहा हूँ, समझा रहा हूँ. एक्सप्लेनेशन या सॉरी की जरूरत नहीं है, डोंट वरी. मैं आपको सिखा रहा हूँ, बस आपको बस याद रखना है. मैं ठीक करा. By the way, tell me, what do you feel these two forces Are they balanced? The normal reaction on the block and the weight on the block. Aren't they balanced forces? Balanced. Okay, Malini Singh balanced. What about others? आप आप लोग की भी तो कोई ओपिनियन होगी. हाँ भाई. What about others? What do you feel? Are these two forces balanced? Okay, my first question is, can you call the forces on the block normal reaction and the weight, can you call them balanced? And the second question is, can you call them as action reaction pair forces? Can you call them action reaction pair forces? Balanced equal forces. Okay, Prasanna and Malini are saying balanced, and Deepika and Pratibha have no answer. But इस simple सी बात के लिए आंसर क्यों नहीं है? डांट लगाना शुरू करूं क्या? Hmm, okay, just give me two answer to both the questions. Pratibha has left the class. बताओ. हाँ दीपिका बताओ. दीपिका बोलो बेटा. बोलो बेटा. हाँ. क्या हुआ? दीपिका also has left the class. ठीक है. Prasanna, what do you think? Do they form action reaction pair? सर एक्चुअली मैसेज सेंड नहीं हो रहे हैं, मैंने हैंड रेज किया तो क्लास एग्जिट हो। अच्छा ओके, अभी तो सेंड हो गया बेटा। अब बताओ मेरे को, द क्वेश्चन रिमेन्स द सेम, whether these two forces are action reaction pair and whether they are balanced. Okay, balanced forces. And what about action reaction pair, Deepika? Do they form action reaction pair? अजी कॉन्सेप्ट समझना बहुत जरूरी है आपके लिए, वरना इतना वेट मैं करता किसी के लिए नहीं हूं, बट ये कॉन्सेप्ट इतना इंपॉर्टेंट है। तो सुना, action reaction and opposite forces acting on object. Okay, action reaction pair. Malini carry action reaction. Prasanna is also saying action reaction. They are forming action reaction. Deepika, do you also feel that both of these forces are forming action reaction pair? ये इतना भी वेट मत कराओ। दीपिका फिर से एग्जिट हो गई क्या क्लास से? ओके, विल मूव ऑन, नो वरीज। See, these two forces are balanced forces, but they are not forming action reaction pair. Okay, why they are not forming action reaction pair? Because they are not the forces applied by two bodies on each other. Okay, for in order to be qualified as action reaction pair, these two forces should be applied by these two bodies on each other. Okay, but in this case you can see that the normal reaction is the force applied by the table on the block, whereas the weight gravitational force is a force which is applied by the earth on the body. Okay, so these are not applied by each other. The force of gravitation, or the weight of the body, is applied by the earth. Okay, so the force W is applied by the earth, and the force normal reaction is applied by the table. So there is no force applied by the block. Okay, so in order to be action reaction forces, the two forces should be applied the by the two objects which are in the system, and these forces should be on each other, not on some other objects. Okay, not like earth should not apply force, A should apply force on B. Okay, which is in the form of normal reaction. So B should also apply some force on A, and B is applying no force on A. Okay, I hope you got my point. Okay, so although they are equal and opposite, okay, they are balanced, they are equal, they are opposite, they do not form action reaction pair because these forces are not applied by two bodies on each other. I hope you understand. If you understand, you can tell me. Yes, sir. Yes, sir. Okay, Malini has understood. I hope, Prasanna, you also have understood. Deepika, आप recording देख लेना बेटा. Now, I will tell you some applications of the third law. So basically, you must have seen firing. आप लोगों ने कभी live firing देखी? आप लोगों ने firing करी तो नहीं होगी. Those of you who have taken NCC must have undergone firing training, but those who have not taken NCC, you don't know how firing looks like. What happens in firing is whenever you fire a bullet, you feel some recoil. Okay, if you're firing from the pistol, the recoil is felt by your hands. If you're firing from a rifle, you know the difference between rifle and pistol. I hope ये तो basic होता है. Rifle बड़ी होती है. Rifle is big in size and pistol is small in size. Okay. Just a minute. Uh, mm, just a minute. I will continue. Your Anurag का issue solve कर दूं. Okay. हाँ मैं क्या बता रहा था. This stupid thing has taken a lot of time. Okay, coming back to the अब मैं आपको application बता रहा था. Whenever you fire a rifle or a gun, you experience some recoiling. Okay, that is the example of an action reaction force. Action is firing of a bullet and reaction is your recoil, which you feel in your hands. Okay. So when a bullet is fired from a gun, it exerts a forward force on the bullet, and a bullet exerts an equal and opposite force on the gun. Okay, so due to the high mass of the gun, it moves a little distance backward and gives a backward jerk to the shoulder of the gunman. Okay, what happens is the law of conservation of momentum. We will read. Okay, law of conservation of momentum. But what is the basis? I'll tell you. What happens generally is gun exerts some force on the bullet. Okay, but bullet is having very small mass, so it acquires a very large velocity, and it has some total momentum. Then mass into velocity, it has some total momentum. Okay, but gun, which was initially at rest before firing, would now also wants to will now also have to be in motion just to counterbalance the momentum gained by the bullet. This is the law of conservation of momentum. हम इसे आगे पढ़ेंगे. Okay, what is in law of conservation of momentum? That the net momentum of the system should remain should remain zero basically. Okay, so if when you fire the bullet has acquired a large velocity. and it also has a small mass. That is why it has acquired a large velocity, whereas the gun is having a large mass. To counterbalance the momentum gained by the bullet, it will acquire a very small velocity. That is why the jerk experienced by the gunman is very less. It's not very high jerk. Okay, whereas the jerk experienced by the man who gets hit by the bullet is very high. It's that high that it leads to death, basically. So you can relate from that. That is an application of Newton's third law, recoiling of a gun. Okay. And another application I've told you, when you walk, okay, to walk, we press the ground backwards with our foot, and in the reaction, the ground pushes us forward. And that is why it is difficult to walk on sand or ice. When our feet presses the sandy ground in backward direction, the sand gets pushed away, and as a result we only get a very small reaction forward from the sandy ground, okay, making it difficult to walk on sand as well as ice. ठीक है, रेत में और उसमें बर्फ में चलना मुश्किल इसीलिए होता है क्योंकि जब आप रेत को बर्फ को पुश करोगे अपने पैरों से पीछे, तो वो पीछे ही चली जाएगी, वो कोई रिएक्शन नहीं देगी. ओके, ग्राउंड में तो कंक्रीट है, ग्राउंड इज कंक्रीट. सो व्हेन यू push the ground backward, it does not go backwards. But sand and ice, they are not that strong. If you push the ice backwards, it will go backwards. It will not give you a forward reaction. That is why it is difficult to walk on ice and sand. Then rocket propulsion. In jets and rockets, the fuel is burned to produce a large quantity of hot gases. I told you. These hot gases come out of the nozzle with a great force, which is called the action. According to the third law of motion, the equal and opposite reaction pushes the rocket upwards with greater speed. This is the reaction. Now, there are many examples like that. When a rubber ball rebounds from the ground, you must have played basketball. Okay, the action is you throw the ball towards the ground, and when the ball bounces back, the basketball bounces back. You must have played basketball. So that is the reaction when the ball is bouncing back after striking the ground. Okay, so this is a small application. There are many other applications which you can read by yourself. And I should move forward. It's already 6:28. Oh my god. चाहिए आप लोगों को break? Do you guys want break or do you guys want me to continue? I will continue anyway. Okay. Let me tell you about some significance of the Newton's laws. I will just read this, just listen to it and try to remember. Okay, the first law, Newton's first law, you all remember? It talks about the state of motion of a body and the motion along a straight line with constant speed. I told you if there is no external force present, a body which is moving in straight line with uniform velocity will continue to move in the straight line. Okay, and the second law, what the second law states? The second law says about if a body is not following its natural state of motion, then there has to be some net unbalanced external force acting on the body. Okay, the rate of change of momentum. What is the rate of change of momentum? Basically means that body is not able to maintain its state of motion. अगर रेस्ट पे है तो रेस्ट पे नहीं रह पा रही है, और बॉडी अगर चल रही है कांस्टेंट वेलोसिटी, तो कांस्टेंट वेलोसिटी से ही चलती नहीं रह पा रही है, उसकी वेलोसिटी में कुछ चेंजेस आ रहे हैं, और रेस्ट पे थी तो मोशन में आ गई. इस तरह को इस तरह की कंडीशंस को बोलते हैं कि अपना स्टेट ऑफ मोशन मेंटेन नहीं कर पा रहा. तो वही वो बात कह रहा है, इफ अ बॉडी इज नॉट एबल टू फॉलो its natural state of motion, then there has to be some unbalanced external force acting on the body. ठीक है, अगर कोई बॉडी अपना स्टेट ऑफ मोशन फॉलो नहीं कर पा रही है, तो इसका मतलब जरूर यकीनन यही है कि इट इज बीइंग एक्टेड अपॉन बाय सम एक्सटर्नल फोर्स. कोई तो है जो उस पे फोर्स लगा रहा है. ठीक है, तो and the third law talks about what? The nature of the force. Okay, nature of the force is action reaction. Okay, they exist in pairs, they are equal in magnitude, opposite in direction. So they talk about the nature. Okay, so these are the significance of three laws in just a summary for you. The three laws are over. So the chapter Newton's laws of motion is over. Anna? No, it is not over. There is a lot of thing left in Newton's laws of motion. The three laws are just a part. Okay, tell me some quick questions. Can we say that the action occurs before the reaction in Newton's third law? अब तो बहुत टाइम लोगे to answer है ना? Can we say that the action reaction act on the same body? Tell me, can we say that the action occurs before the reaction? And can we say that the action reaction act on the same body? Sir, Prasanna, what is that which is troubling you? Yes, Prasanna. My two questions. Okay, first question is, can we say that action occurs before the reaction? Second question is, can we say that action and reaction act on the same body? Just tell me whether yes or no. Then we'll move ahead. Good. First no, second yes. First no, second yes. First no, second yes. Very good. All of you are duffers. All of you. Both of them are no, beta. Both of them are no. Second is also no. Second question was, can we say that action and reaction act on the same body? No, they always act on the different bodies. I told you just now, na, action and reaction act on different bodies. Action kya hai? You are walking on the ground. You took action on the ground. You pushed the ground backwards. And in the reaction, ground pushed you forward. So action force is taking place on the ground by you. And reaction forces by the ground on you. So different bodies. Both of the action reaction forces are acting on different bodies. Both of them are no. Only one no and second yes. और सारे proud feel कर रहे हैं. Malini explanation भी दे रही है. Action reaction is at the same time. There is no time gap. Okay, you answered one correct. What about the one you not answered? Okay, always talk about always address your failures first, and not try to celebrate your success. Always address your failures. Okay, I'll give you a fun question. What's a fun question? A fun question is a fun question. Okay, what is a fun question? The momentum P of a particle, the momentum P of a particle is varying with time as P is equals to 2 plus 3t square. Calculate the force acting on the Particle. I will not explain this question. I'll just simply write the question. You have to give me the answer. At t is equals to 3 seconds. Okay, just tell me the answer for this question. Everybody, just try to answer this question. I'll be just back. Yeah. Out of 3 people, 2 answers, 12 and 18. Prasanna, what is your answer? This was supposed to be a fun question, so you have to answer. Prasanna, 10 seconds more. Okay, your time up. I didn't got. Okay, no problem. Question is pretty simple, by the way. The momentum of the particle is given to you as 2 plus 3t square. It is a varying momentum with time when you want to calculate the force. Okay, so you can see that the momentum is changing with time. So this is a case of changing momentum. So you have to calculate impulse. So basically, force is not impulse is also a type of force, and that impulse was used to be dp by dt, differentiation of momentum with respect to time. That is how you calculate changing momentum with respect to time. So if you differentiate this, you will get your answer as 60. And I'm asking you at 3 seconds. So put the value of 6 as 3. The answer will be 18. ठीक है मालिनी? दे दो मुझे कोई अच्छा सा एक्सक्यूज बेटा. सर वो मैं ना 2 को 8 बोलती हूँ. Whatever may be your excuse, I don't want to go in that, but not expected. Simple question. Now let me tell you. Let us read about conservation of Oho. Who is messaging me? What I was telling you. We'll read about conservation of momentum now, and I will use encoder for that. Yes sir. Okay sir. किस बात पे ओके बोल रहे हो तुम? वलिनी डांट पड़ रही है, ओके बोल रही हो? अच्छा, गट्सी हो गया, गट्सी. बट अभी तो डांट मैंने मारी नहीं है, अभी मैं प्यार से समझा रहा हूँ, सुधर जाओ. सिंपल कैलकुलेशंस गलत कर रहे हो तो खुद ही देखो ना, फिर आप कैसे आप कंप्लीट करोगे ना, इतना बड़ा एग्जाम है. आप तो एक बार दे चुके हो एग्जाम. यू नो द लेवल ऑफ कंपटीशन. द स्टूडेंट्स इन various states are preparing day and night. Conservation of momentum. Now, what is conservation of momentum? I first tell you in English and then Hindi. Conservation of momentum is a law of physics which states that the total momentum of an isolated system should remain conserved. Okay, very simple, not very simple. If I'll simplify, I would like to say, if there is no external force acting on a system, okay, if there is no external force, there is no external force means the total force or the net force on the system is zero. Okay, if there is no net external force on the system, then the total momentum remains conserved. For an isolated system, the initial momentum of the system will be equal to the final momentum of the system. Okay, I will repeat this in Hindi as well. बेसिकली ये लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम क्या कहता है कि अगर किसी सिस्टम पे, कोई सिस्टम है, सिस्टम कुछ भी हो सकता है, ठीक है, 2 ब्लॉक्स आपस में कनेक्टेड है, एक ब्लॉक एक टेबल पे रखा है, इस तरह की कोई भी सिस्टम हो सकता है. तो अगर एक सिस्टम पे बाहर से कोई एक्सटर्नल फोर्स नहीं लग रहा है, ठीक है, नेट एक्सटर्नल फोर्स जीरो है, बाहर से लगने वाला एक्सटर्नल फोर्स सिस्टम के ऊपर जीरो है, तो उस केस में क्या होगा, सिस्टम का बेटा, सिस्टम का जो मोमेंटम होगा ना, इनिशियल मोमेंटम, वो बराबर होगा किसके, फाइनल मोमेंटम के. इनिशियल मोमेंटम आपने जब ऑब्जर्व करना स्टार्ट किया इनिशियल, और फिर जिस टाइम पे आपने ऑब्जर्वेशन बंद कर दिया, तो उन दोनों टाइम पर पे आपको मोमेंटम कंजर्व रहना चाहिए. देयर शुड बी नो चेंज इन द मोमेंटम ऑफ द सिस्टम. क्योंकि मैंने क्या बताया था न्यूटन सेकंड लॉ ऑफ मोशन से, कि दैट चेंज इन मोमेंटम produced in a system is only due to a net external force, and it is directly proportional to the magnitude of the or the intensity of the external force. So change in momentum is produced only by an external force. if there is no external force, if this external force is totally absent, there is no net external force acting on a system, so the total momentum of that system should remain conserved. Okay, that is the initial momentum will be equal to your final momentum. Take it. So let's take an example. If you consider two blocks, okay, of mass m1 and m2, let me just draw it like this. These are the two blocks, mass m1 and mass m2. Okay, the mass m1 block is moving with velocity u1. That is called as block A. It's called B, and the m2 mass is moving with velocity v2. Sorry, u2. u2. These are the initial speeds. Initial speed. Then what happened? Both the masses collided. Okay, m1 collided with m2. A, B. Okay, so when they collided, the block B experienced some force by the block A. So I can write it as force on the second block. This is M2, so second block by the first block M1. And I can say some other force experienced by the block M1 due to M2. So force on block 1 M1 due to block M2 F12. Now both the forces will be in opposite direction because they have collided, and when two people collide, they exert force on each other in opposite directions. Okay, so they collided for some time, and after that they again separated, and they again start moving. So after collision, the M1 started moving with speed v1 and M2 started moving with speed v2. Okay, this is after collision. Final. Okay, this is during collision. During collision. These are the cases. Okay, if I say that the initial speed of block A1, which was u1, is greater than initial speed of block u2, okay, and then they collided and they the force were exerted on each other. Okay, so F21 is the force exerted on the block B by the block A. Okay, and F12 is, what is F12? Force exerted on the block 1 by the block 2. M2 is your block 2, MA is your block 1. So A1 B2 लिख दिया है मैंने. Okay, and v1 and v2 are the velocities after collision of the block respectively. v1 is for the block A and v2 is the velocity after collision for block B. Okay, now if I say the momentum before collision, okay, momentum of system let us talk individually. Momentum of block B, okay, B before collision will be what? M2u2. Momentum of B after collision will be M2v2. This is u beta, u2. Similarly, momentum of A before collision will be what? M1u1, mass into velocity. Momentum of A after collision will be M1v1. All right. So can I say the rate of change of momentum of any block, let it be B or A, is equal to the force exerted by the, let's talk about the block B. So rate of change of momentum of block B will be equal to the force exerted by the block A on block B. Let me write it now. आपको तब ज़्यादा समझ में आएगा. rate of change you understand this? Rate of change of momentum of B will be equal to force on B, which is what is 2. 2 is block B. Force on 2 by block 1. Force on B है ना by block A. इसको ऐसे लिख सकते हो आप force on B by A. Okay. So you can write the rate. How will you write the change in momentum? Final momentum of B minus initial momentum of B upon time taken for the change T. Okay, and if I take M2 common, you can simply write V2 minus U2 upon T. And similarly, you can calculate the rate of change of momentum for A. Okay, that will be. समझ में आ रहा है ये क्या राम कथा चल रही है? Do you guys understanding what is going on? क्योंकि आप दोनों को इंग्लिश भी समझ आ जाती है तो मैं कंटिन्यूसली आई एम स्पीकिंग इन इंग्लिश ओनली. I'm not using Hindi. So are you guys getting it? Malini and Deepika? क्या चला इतनी देर से समझ में आया ना? थोड़ा थोड़ा तो आया होगा. Taking M1 common, you can write V1 minus U1 upon T. Okay, so that's how you calculate the rate of change of momentum of B. This is rate of change of momentum of A. Rate of change in momentum of A. Okay, will be equal to F12. Now, according to Newton's third law of motion, the action reaction forces are equal and opposite. So, what is the action? Okay, we can call anyone. Okay, you can call F21 as action or F12 as action. Okay, let me call force experienced by the A block by the B block as action. This was an action force. This will be equal to the opposite of force experienced by the B block due to A block. F21. F12 is action and F21 is your reaction. Okay. If you are getting confused, you can see the above diagram. What was action? Okay, this is I'm calling action. Force experienced by the block A and by due to block B, and the force experienced by block B F21 due to block A, I'm calling this as reaction. Okay, so this is from Newton's third law of motion. We can say that F12 action is equal to opposite action reaction are equal and opposite in direction. Okay, so this is what you should remember. So we can basically say M1 into V1 minus U1 upon T is equals to M2 into V2 minus U2 upon T, and T will get cancelled. So you can basically say M1 U1 plus M2 U2 is equals to M1 V1 plus M2 U2. This is total initial momentum of system. Total initial momentum of system is equal to final final initial. कैसे लिख सकता हूँ मैं? फाइनल लिख रहा हूँ तो टोटल लिखना ना. हाँ, मैं भी ना. बिग बॉस देखते हो आप लोग? You guys watch Big Boss? बड़ा इंटरेस्टिंग आता है, नहीं देखते क्या? कोई नहीं देखता आप में से बिग बॉस? समझ आ रहा है, ओके गुड. What was the derivation of the whole law? The whole law basically says that the initial momentum of the system is equal to the final momentum of the system. That is basically the law of uh, conservation of momentum. This is the main formula. Okay, m1 u1 plus m2 u2 will be equal to your m1 v1 plus m2 v2. Okay, I hope you all have understood this. Based on this, I can give you a question, and till the time I'm giving you a question, what you have to do is you have to tell me whether you watch Big Boss or not. क्या है सर? सीरियसली पूछ रहे थे आप? यस, सीरियसली सीरियसली, ऐसे मजाक थोड़ी करता हूँ. अपने आप से बात कर रहा हूँ, मुझे लग रहा है. मुझे हर रोज यही लगता है, मैं अपने आप से बात करता हूँ, क्योंकि आप लोग के पास तो माइक नहीं है. तब देखता हूँ ना, अक्सर बोलते बोलते रुक जाता हूँ मैं. ये उम्मीद करता हूँ कि कोई बच्चा माइक अनम्यूट करेगा और बोलेगा. मुझे गूगल मीट वाली आदत हो गई है अच्छे से. बट एक बात बताऊं आप लोगों को, वेरी 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 रियल. मैं आपको एक बात बताता हूँ, बहुत ज्यादा रियल बात है ये. About your NEET exam only. I don't know whether how many of you are studying properly or not, क्योंकि हो सकता है कि हर एक बच्चा ना ज्यादा वो ना करता हो. मतलब क्या बोलते हैं उसे, दिखावा एंड शो ऑफ. नॉट एवरीबडी शोज ऑफ. There is chances that you all of you might be reading quietly, and you all must be working hard. But if in the case you are not working hard, okay, then I must tell you that this is the time to start working hard. 4 months only, 4 months only, and you have to compete with the students who are, staying in quota and whatnot in hostels, and they have, dropped for 2 years, 3 years rigorously they are studying. Okay, some are in 12th class. Okay, they have done 2 years of quota coaching, and some are they are in there. What is a hostel life? Hostel life is you have nothing to do. You have to study only. So you have to compete with students who are studying 24 hours a day. Okay, I'm not joking. Students do study 24 hours a day. Students have stopped sleeping for this exam because it's a do or die situation for them. Their parents cannot afford, the huge fees of private colleges, and government colleges are the only option for them. So they are studying in, financial crisis. So they are very much hardworking. So you have to be equally hardworking in order to compete with them. ओके, उतना ही हार्डवर्क करने के लिए आपके पास एक स्ट्रॉन्ग रीजन होना चाहिए. जब तक आपके पास स्ट्रॉन्ग रीजन नहीं होगा, आपका मन नहीं लगेगा पढ़ाई में. देखना, कुछ भी करने के लिए ना एक स्ट्रॉन्ग रीजन होना चाहिए फॉर एवरीथिंग इन लाइफ. यू शुड हैव अ स्ट्रॉन्ग रीजन व्हाई आई एम डूइंग इट. तभी आप उसको 100% कर पाओगे, तभी डेडिकेशन से दे पाओगे. ओके, यू कैन नॉट लर्न एनीथिंग if you do not have dedication. So there should be dedication. For that dedication there should be realization that why you want to be a doctor. Why? ठीक है, आपका why बहुत strong होना चाहिए. मैंने आपको कितनी बार बोला है, अगर आपने पढ़ना स्टार्ट नहीं किया तो अपना वाई आइडेंटिफाई करो और अब पढ़ना स्टार्ट कर दो. ठीक है, जस्ट थिंक दैट यू विल गिव योर बेस्ट शॉट. ओके, और डोंट वरी व्हाट टाइम हैज गॉन. इट्स गॉन, नोबडी कैन डू दैट. बट स्टार्ट स्टडीइंग नाउ एंड सॉल्विंग क्वेश्चन एज वेल. मतलब मैं बोल रहा हूँ, यू हैव टू सॉल्व द क्वेश्चन साइड बाय साइड. A bullet of mass 50 gram is fired from a gun with initial velocity of 35 meters per second. If mass of the gun is 4 kg, then calculate the recoil velocity of the gun. You have to calculate the recoil velocity of the gun, and you have to start focusing in life, because वो डे ना बहुत पेनफुल होगा. ठीक है, अभी तो आप मस्ती कर लोगे फेब तक, मार्च तक, आपको सडन रियलाइजेशन विल हिट यू दैट ओनली 1 मंथ इज लेफ्ट एंड यू आर स्टैंडिंग एट पोजीशन 0। और फिर आप क्या करोगे, बहुत सारे स्ट्रैटेजी वीडियो देखोगे, 1 महीने में कैसे लाएं 700 नंबर, और उससे होता कुछ नहीं है, 300 भी नहीं आते, पॉसिबल ही नहीं है प्रैक्टिकली 1 महीने में आप 700 नंबर ले आओ यार, इफ यू आर बॉर्न जीनियस, है ना। और बॉर्न जीनियस तो एक महीना भी नहीं पड़ेगा, बट यू आर एवरेज स्टूडेंट्स, वी ऑल आर एवरेज स्टूडेंट्स, ओके। यू नीड टू स्टडी टू ईयर्स टू क्रैक दिस एग्जाम। ऐसी गवर्नमेंट ने पागल नहीं है कि आपको 2 साल का टाइम दिया हुआ है इस एग्जाम के लिए, ठीक है। गवर्नमेंट इज वेरी वेरी इंटेलिजेंट, दे हैव गिवन 2 years of time because they know, because 2 years of time is the minimum amount of time required to crack this exam. 2 years की पढ़ाई 1 month में पॉसिबल नहीं है ना। कितना भी एफिशिएंट हो जाओ, उस 1 महीने में आप 2 साल के बराबर पढ़ाई नहीं कर सकते। So think about your why because वो बहुत पेनफुल दिन होगा जिस दिन एग्जाम दे करके आओगे ना, और आपका चेहरा लटका हुआ होगा, रोकने का मन करेगा बहुत जोर से, मैं बता रहा हूँ। देखा है लोगों को रोते हुए, मैंने देखा है लोगों को डिप्रेशन में जाते हुए, ठीक है। वो फैमिली को फेस नहीं कर पाते हैं, उनके पास कोई आंसर ही नहीं होता देने के लिए कि क्या किया 2 साल 3 साल। पेरेंट्स तो पूछेंगे ना क्या किया बेटा, तो बहुत डिफिकल्ट हो जाता है और बहुत मेंटली मेंटली बहुत टॉर्चर होता है। इसलिए अभी मेहनत कर लो, मेहनत करी, कम से कम ये तो बोल सकते हो, एक प्राउडली ये बोल सकते हो कि मैंने मेहनत पूरी करी थी, नहीं हुआ नहीं हुआ, ठीक है। बट उस दिन कुछ नहीं बोल पाओगे जब मेहनत भी नहीं करोगे, जुबान लड़खड़ा जाएगी तुम्हारी, कुछ नहीं बोल पाओगे, बस ये बोलोगे कि ड्रॉप और ले लेता हूँ, क्योंकि तुमको और कुछ पता ही नहीं है उसके अलावा। सो दैट रियलिटी इज वेरी वेरी हार्श, ठीक है। You will be crying, you will be dejected, you will feel like a failure, ठीक है, because you have given this that much importance to this exam. You have given your 2 years of your precious age, youth, is very 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 much of a cost to give. बहुत ज्यादा बड़ी कीमत है ये। तो उसके बाद आपको रिजल्ट नहीं मिलेगा ना, तो बेचैन हो जाओगे, आपको मुझे रिजल्ट चाहिए। तो देखोगे साथ में इधर उधर से बच्चे सिलेक्ट होके जा रहे हैं, स्टेटस डाल रहे हैं, फर्स्ट व्यू ऑफ द मेडिकल कॉलेज फोटो डाल रहे हैं सीनियर्स के साथ, फ्रेशर्स हो रहा है, पार्टी हो रही है ना। बुक्स की फोटो डाल रहे हैं, एनाटॉमी की बुक ले ली, बायोकेमिस्ट्री की बुक ले ली, सडन डिप्रेशन हिट करेगा, सबसे दूर भागने का मन करेगा, ठीक है। और फिर याद करोगे कि दिसंबर का महीना था, और सर कह रहे थे अब भी ढंग से पढ़ना शुरू कर दो। पीछे का टाइम याद करोगे नीट के एग्जाम से एक दिन पहले की काश आज दिसंबर होता और आज मेरे पास और 4 महीने होते तो मैं बहुत बड़े रिजल्ट लेकर के आता। तो डोंट लेट योरसेल्फ टू गो इन दैट सिचुएशन। आई वांट कि इस बैच से एटलीस्ट 2 से 3 बच्चे सिलेक्शन दें, आई वांट एटलीस्ट 3 स्टूडेंट्स टू गेट सिलेक्टेड। तो प्लीज 3 of you try to get selected, try to get selected। और किसी के बताने से नहीं होता यार, कोई हमें किसी ने स्ट्रैटेजी नहीं बताई थी, और मैं कितनी भी स्ट्रैटेजी बता लूं, कितनी भी टिप्स बता लूं, वो नहीं हो पाता है फॉलो। किसी की बताई हुई टिप्स कैसे फॉलो कर सकते हो 100%, ठीक है 20-30% बता दिए, वो 30% 40% यू कैन फॉलो, बट हमें अपनी स्ट्रैटेजी खुद बनानी है, अपनी स्ट्रैटेजी खुद ट्राई करनी है, एक स्ट्रैटेजी अपनानी है, उसको इस पर पढ़ के देखना है, मॉक देना है, टेस्ट देना है, ठीक है। उस और अपनी स्ट्रैटेजी को चेंज करना उस हिसाब से, प्रैक्टिस कर करके, एग्जाम दे दे के, टेस्ट दे दे के। तो ट्राई बी स्टार्ट बीइंग अ बिट सीरियस। मैं बता रहा हूँ तुम लोग नहीं झेल पाओगे वो फेलियर, ठीक है, क्योंकि तुम लोग बहुत ज्यादा ना, क्या बोलूं मैं, यू आर नॉट वेरी इमोशनली स्ट्रॉन्ग एट दिस एज। आप इमोशनली स्ट्रॉन्ग नहीं होते हो बहुत ज्यादा। आई एम टेलिंग यू विद अ वेरी क्लोज एक्सपीरियंस, ओके। पढ़ाई, अगर आपको लगता है कि आप पढ़ाई करने के लिए बने हो तो पढ़ाई अच्छे से करो, अगर कोई और टैलेंट है तो गो दैट, ओके, इट्स नॉट एट ऑल। देखो मैं आपको बता दूं, डॉक्टर बनना जिंदगी में कुछ नहीं होता है। अगर आपको लगता है कि नेम है, फेम है, नथिंग, बुलशिट। नेम फेम तो कुछ नहीं, चला जाएगा आपका। व्हेन यू विल क्रॉस 65 आप पेशेंट्स देखने बंद करोगे, यू विल स्टार्ट स्पेंडिंग टाइम एट होम, चला जाएगा आपका नेम फेम। तो डोंट डू दिस फॉर नेम फेम, इसके लिए मत करना मेडिकल फील्ड कभी भी। तभी मैं कहता हूँ आपका वाई बहुत स्ट्रांग होना चाहिए. It's absolutely okay if you don't want to do it. It's okay. Doctoring MBBS is not the only way of life living. Okay, you can be a fantastic scientist, a fantastic microbiologist, a researcher. You can be a accountant, a CA, a pilot, a lawyer. Okay, you can be a defense person. Okay, you can be a stockbroker. You can be a crypto investor. Okay, you can be a businessman. Anything. Just try to identify your passion. और अगर तुम्हें लगता है कि पढ़ाई ही तुम्हारा पैशन है, उसके अलावा तुम कुछ नहीं कर सकते, ठीक है. होता है ना, बहुत बच्चे होते हैं स्पोर्ट्स में ट्राई करते हैं, इधर उधर ट्राई करते हैं, उतना ग्रो नहीं कर पाते, फिर पढ़ाई करते हैं तो दे ग्रो वेल इन स्टडीज. क्योंकि स्टडी में सबसे ज्यादा ब्रांच है, स्पोर्ट्स में इतनी ब्रांच नहीं. कितने स्पोर्ट्स हैं ले देखा कि 25-30 है ना, 35 स्पोर्ट्स हैं. ओलंपिक्स में कितने स्पोर्ट्स होते हैं? 35 स्पोर्ट्स होते हैं ना. कितने ठीक है. और हर स्पोर्ट्स तो ठीक है. और नॉर्मल पर्सन कैन नॉट बी ए जिम्नास्ट, जिसको स्विमिंग नहीं आती वो स्विमिंग नहीं कर सकता. सो फिर आपका नैरो डाउन हो जाता है ना क्राइटेरिया. ऐसी अदर फील्ड्स में भी है. बट स्टडी में क्या है, बहुत वेरिएशन है. डॉक्टर, इंजीनियर, लॉयर, सीए, अकाउंटेंट, कुछ भी पढ़ सकते हो आप, जो मन करे. तो अगर आपको लगता है कि पढ़ाई के लिए बनो, तो एक सब्जेक्ट अपना आइडेंटिफाई कर लो, उसमें आपको इंटरेस्ट आता हो. स्टडी सीरियसली, स्टडी सीरियसली. इट्स 7-7 0.44 0.43. ओके, क्या क्वेश्चन दिया था मैंने? इतनी बात करी ना बेटा, मैं क्वेश्चन से ही निकल गया ना. थोड़ा एक बार क्वेश्चन देख लेना. 35 मीटर पर सेकेंड, मास ऑफ द गन इज 4, देन कैलकुलेट दी recoil velocity. 0.44 is the correct answer. Very good. 0.43 आ रहा है. You are also right, but actually उसी के आसपास आएगा. 0.4443 कोई फर्क नहीं है. आपने अप्रोक्सीमेशन नहीं करा, आमतौर पर अप्रोक्सीमेशन कर देना था. Not at all. 0.4 0.4 both are correct. Okay, so good. You have solved this correct. This question is correct. No. What more do you want to study? Recoil of a gun पढ़ोगे? Recoil of a gun is the application of Newton's law of conservation of momentum. Recoil of gun में क्या होता है? Suppose this is a gun. This is a gun. It has a bullet inside it. Okay, so initial momentum, P initial momentum of the system, bullet and gun, okay, is equal to 0 because the gun is and bullet both are at rest. Okay, so initial momentum is 0. But what will happen if you fire this gun? If you fire this gun, this is the bullet. अजीब सी ये bullet थोड़ी सी ना. The bullet is having some small mass m and a capital V velocity. The gun is having mass capital M and it is having a small u velocity. Now both the velocities are in different directions. You know why? Because अभी आपको पढ़ा है मैंने recoiling of gun. Okay, that the gun experiences a jerk in backward direction when the bullet is fired forwards. Okay, action reaction बताया ना अभी आपको. So that is that only. Okay, so what I told you that the initial momentum should be equal to the final momentum. P final and initial should be equal. So P final should also be equal to 0. But what you can see is that it is not 0. Bullet has some momentum and gun also has some momentum. But both of the momentum of the bullet and of the gun are in opposite directions. So they must be equal in order to produce a result equal to 0. Because they are in opposite directions. If they are equal and in opposite direction, so the net momentum of the system will be 0 again, which should be 0 because of the law of conservation of momentum. ठीक है ना. लॉ ऑफ कंजर्वेशन मोमेंटम की वजह से 0 होना चाहिए. जो इनिशियली था वही फाइनली भी होना चाहिए. लेकिन फाइनली आपने देखा कि बुलेट और गन दोनों ने अलग अलग वेलोसिटीज एक्वायर कर ली. लेकिन देखो दोनों अपोजिट डायरेक्शन में है. द वेलोसिटीज ऑफ बोथ द बुलेट एंड द गन आर इन अपोजिट डायरेक्शंस. हेंस देयर मोमेंटम आर इन अपोजिट डायरेक्शंस. नाउ इफ देयर मोमेंटम्स आर इक्वल, द नेट रिजल्ट ऑफ द सिस्टम ऑफ गन प्लस बुलेट will give you a result of 0. So ये This is the formula which comes out of this recoiling of gun. Right? The what is the momentum of, simply it says momentum of bullet after firing. Momentum of bullet after firing is equal to momentum of gun आफ्टर फायरिंग. ठीक है, गन और बुलेट का आफ्टर फायरिंग मोमेंटम इक्वल कर देना. ठीक है, दिस इज द ओनली application. And the other one is the rocket propulsion. What is rocket propulsion? Rocket propulsion is based on Newton's third law. I gave you the example ना, action reaction pair होते हैं rocket propulsion में. So it is based on Newton's third law because there are action reaction forces involved in rocket propulsion. Third law. So basically what happens, okay, now the fuel is stored inside this rocket. So the rocket starts to burn. When the rocket starts to burn, it ejects the fuel through this nozzle. Okay, this is a nozzle. So the fuel inside the rocket is now getting burned and getting, it is exiting with a very high force, exiting from the rocket, okay, with a high force. This is after burning. The fuel is getting exerted through the nozzle at a very high force. Okay, these are the fuel is what gases only. There are some gases you will study in rocket engineering. Rocket science में आप पढ़ोगे क्या कौन सी gases are used for rocket propulsion. ठीक है ना, किस उस mixture में what is what. Okay, this is all rocket science. So you need not to go inside the rocket science. You should just listen what I'm trying to say. Okay, so the gases are getting ejected out of the nozzle with a very high force. This is the action. Okay, this is the action. In reaction, the rocket will feel an upward force by the ground. Okay, upward thrust. This force is also called as upward thrust. This is on rocket. Upward thrust on rocket. Okay, due to the burning of gases, the ground will, this is reaction, the ground will push it upwards with a thrust force. Okay, the ground will push the rocket upwards. So basically the thrust force by the ground, this is thrust force, is equal to the force by exhaust gases. Okay, the force exerted by the gases on the ground, okay, it is equal to the force exerted by the ground, which is called as thrust. So force exerted by the exhaust gas is equal to the force exerted by the ground. Okay, and how can you calculate the rate at which the fuel is burning? So the formula to calculate the rate at which the fuel is burning, rate of fuel burning, is nothing but dm by dt, the rate at which the mass is changing, because mass of the rocket is decided by how much fuel it is containing. Okay, so as the fuel starts to burn, the mass inside the rocket will decrease. Okay, so dm by dt, the rate at which the mass is decreasing, is also the rate at which the fuel is burning. Okay, और पढ़ा देता हूँ आज के लिए और थोड़ा सा. वेट अ मिनट. अच्छा, पहले आपको डायग्राम बना के देता हूँ, then you will understand this better. M naught is the initial mass, okay, of the rocket, and v naught is the initial velocity at the rocket, because we are observing this at time is equal to 0 seconds. So m naught and v naught are initial mass and initial velocity of the rocket. Okay. Now, after some time t, what will happen? क्लास आप लोग बोरिंग हो गया क्या? ज्यादा पढ़ा दिया क्या? After some time t, now at time is t seconds, the mass is m and the velocity is v. So m and v are your mass of rocket. M is your mass of rocket, and v is your velocity of rocket. After some time, t. Okay. What is the one thing you should always remember? Okay, which I forgot to mention. There is this speed u. There is this speed u. What is speed u? I forgot to mention this. U is the speed of exhaust gases. Speed of burning of exhaust gases. Speed of burning of exhaust gases. Exhaust gases are gases inside the rocket which are used as a fuel to propel the rocket to the acquired altitude. Okay, जिस ऑल्टीट्यूड तक पहुंचाना है, जिस हाइट तक रॉकेट को पहुंचाना है, उसके लिए कितना फ्यूल लगेगा, वो गैसेस के फॉर्म में फ्यूल होता है रॉकेट के अंदर. ठीक है, ये सब इतना सोचना मत, ये सब मैं बता रहा हूँ आपको. दिस इज नॉट योर गेम, दिस इज रॉकेट साइंस. ठीक है, ये साइंटिस्ट लोग पढ़ते हैं. दिस इज नॉट योर गेम. योर गेम इज वेरी बेसिक इन दिस. ठीक है. What you should remember is that the speed at which the gases are getting exhausted, this is called as U. Okay, speed of burning of the exhaust gases relative to rocket. This speed is relative to rocket. Rocket के respect में किस speed से gases are getting burned. Relative means with respect to rocket, at what speed the gases are getting burned. That is represented by U. Then you have no direct speed of burning of gases. Okay, you do not have a direct speed. You have a relative speed. Okay, relative to rocket. ओके, रिलेटिव मतलब रॉकेट किस वेलोसिटी से ऊपर जा रहा है, उसके रिस्पेक्ट में किस वेलोसिटी से आपकी किस रेट से आपकी जो है गैसेस बर्न हो रही है. ओके, रिलेटिव बेसिकली मींस the velocity with which the rocket is going upwards with respect to that, at what rate the gases are getting burned. So you have a relative speed of burning gases. Okay, so these were some basic things about this. Relative पता है ना, what you can call u as your velocity of gases burning minus velocity of your rocket going upwards. So Vg minus Pr is your relative velocity of burning of gases with respect to the rocket. So the force experienced or the force exerted by the exhaust gases can be calculated as the relative velocity of the burning of gases multiplied with the changing mass. U is equals to dm by dt. Okay, and this is the first formula. Second formula is, ये बस आपको याद रखना है, इसमें कुछ ज्यादा नहीं है. इसमें डेरिवेशन में मत पढ़ना क्या कैसे है, बिकॉज ये रॉकेट साइंस है, आपके मतलब का है नहीं है. वैसे ये तो डेरिवेशन नहीं है, ये नहीं है डेरिवेशन, बट वो है कि व्हाट इज रिलेटिव टू बर्निंग फ्यूल एंड ऑल एंड ऑल. दिस इज नॉट डेरिवेशन. ये तो आपको du dm by dt मैंने आपको कराया था ना. F is equals to ma का डेरिवेशन. I've explained you how F is equals to ma is derived, right, in Newton's second law, if you remember. But I hope nobody is remembering. I do not hope. I have a feeling. What we used to do, we wrote F is equals to dp by dt, and then we put the value of mass and v in the place of p. P की जगह पे m भी रखा था, Okay, then we said that F is equals to m dv by dt plus v dm by dt. So in this case, your velocity is constant and your mass is changing. So your formula to calculate force will be u into dm by dt. Same for thrust. Thrust of the rocket is also same. Okay, because their action reaction force they will be same in magnitude. So u dm by dt, same formula. Okay, but velocity v of rocket, velocity of rocket after time t, after some time t. So v will be initial velocity v naught. This is your initial velocity plus log e exponential log e upon log e raised to the power m naught upon m, where m naught is your initial mass and m is your mass at time t. So generally बहुत सारे क्वेश्चन आते नहीं है, but if it comes, you have some formulas to solve, and I'm looking for some questions जो आपको मैं करा सकूं in this. Okay, one more concept is there in this. How do you calculate the acceleration of the rocket? They might ask you acceleration of the rocket while going upwards. ठीक है, किस रेट से जा रहा है? तो acceleration of rocket is basically दो फोर्स लग रही है ना, एक तो थ्रस्ट फोर्स लग रही है. There are two forces on the rocket. This is not your rocket. This rocket should look like a rocket. Okay, there are two forces on the rocket. One is your upward force, F thrust. Okay, and one is your downward force, mg, acting on the rocket. ठीक है, these are the two forces, which out of which the mg is changing continuously. So your acceleration of the rocket at any given time will be F thrust, your thrust force, minus your mg will be your net force, ma. Okay, so this how to calculate the net force on the rocket. Your thrust force minus your gravitational force, ये change हो रहा है लगातार because mass is changing, minus mg is equals to your net force ma. This is your net force on the rocket in a given time. Okay, so if I'm about to give you a question related to this, suppose force experienced by a rocket having exhaust velocity of 300 meter per second is 210 newtons. So force experienced by a rocket having exhaust velocity is 210 newton. This is 210 newton. You have to calculate the rate of combustion of fuel. I've twisted the language of question. Okay, rate of combustion of fuel. What is the rate of combustion of fuel? Rate of combustion of fuel is dm by dt. Okay, the rate at which the mass is getting consumed. So you have to calculate dm by dt. Okay, and the force is given to you and the exhaust velocity is given to you. Very simple question. You have to try. I've given you the hint also. Try to calculate this question. This is the last for the day. इसके बाद आपको free कर देंगे. Dreamum, wake upum, critical conditionum. Let me see if how many of you are able to solve it. 0.7. We have one answer as 0.7. What about others? Message reaching late 0.4. 0. अच्छा ये पहले का 0.4 है. Zero 0.7 and 0.6 are the two answers. Very close to each other. Okay. The correct answer is 0.7. And how do you do that? I'll tell you. See, the thrust force is given to you as 210. Okay. So thrust force is equal to u dm by dt. है ना? हाँ की ना? F thrust. What is the formula? F thrust is equal to u dm by dt. Now, you want to calculate dm by dt out of this. F thrust is 210. U is equal to 300. You want to calculate dm by dt. Very simple. 2110 divided by 300. You will get your dm by dt. Simple. It is simple. Okay. And just to calculate, this is 7 and 10. Yeah, 0.7. 3 7 is 21, 3 10 is 30. Okay. Okay, I free you guys. But do you guys remember what all I told you today? Majorly in the last 20-25 minutes I gave a lecture. Not a lecture, just a talk, you can say. Okay, it was not merely because the exam is in, it was to make you guys realize what you are, what guys you are in, what you are doing. You know, you are into some serious business. Career making is a very, very serious business, so you should be aware of that. You should be aware of your responsibilities. You are not small kids anymore. ठीक है, ये 18 को 12 लिख देते हो और फिर कह देते हो सॉरी सर कैलकुलेशन मिस्टेक हो गया. You need to understand your responsibility. You need to be so serious about it. I'm not targeting anyone here. ये आप सब करते हो. You all do small mistakes at this time also. I don't know about whether you're doing this in chemistry or biology, but you are doing in physics. And you cannot get selected without this subject. You cannot कितना भी ignore कर लो, you will not be able to get selected without physics. You have to improve your physics. So the only way out is to start studying, and study with easy questions, easy solved examples. Okay, start with them. Do not get JEE advanced and JEE main questions in the previous. Start with solved questions, then questions from DC Pandey book. Okay, and then questions of NEET previous year, and that's it. You do that much, you will be good to go. But start with solved examples. Okay, the questions which I give you in class, and the questions which are in NCRT, solved questions in NCRT, and the other books you might be having, MTG fingertips, and like that. So okay, this is some serious business. Okay. Yes, sir. Okay, Malini, good.